Now we have this question on the board here under application of differentiation. And now we are asked to find the gradient of the curve x squared plus 4xy squared plus 5y equal to 26 at the point 3, 1. Now if you look at the function given to us, this is an implicit function, so we can say that f of x, y is equal to x squared plus 4xy squared plus 5y. This 26, I'll move it to this side, they'll have minus 26. As an implicit function, because it depends on x and y, you can see that there. We are now going to differentiate this. Is that okay? Now please, anytime you hear gradient is simply dy dx. Go and differentiate. Then the point given to you for x and y coordinates, you substitute it wherever you see x and y in your dy dx. Now we are going to differentiate this. Already we have established the implicit differentiation formula, which is minus del f over del x all over del f over what? Del y. You can check that from our previous videos. And so we're going to apply that. Now let us go. It will be negative, that is the numerator we're differentiating partially with respect to x. This will give us 2x. Then come over here plus. If you look at this term, 4y squared will be kept constant. Differentiate this x alone that is multiplying it. If you differentiate x, you're going to get 1. So this is 4y squared kept constant times derivative of x, which will give you 1. Then look at this, there is no x multiplying that 5y, no x here, therefore the derivative of this partially with respect to x is 0. No x here as well, so its derivative is also what? 0. We are done with that. Then all over, come to the function again and then differentiate this time around partially with respect to what? Y, to obtain the denominator. Here there is no y multiplying this x squared here, so this is 0. You come over here, you have y squared, so keep 4x constant and then differentiate this y squared. That's going to give us 2y, then plus, come over here, differentiate 5y with respect to y, and then you're going to get 5. This is 0 if you differentiate a constant. Now, what we are asked to find is the gradient at a given point. You see, at this stage now, I don't need to punish myself simplifying this. And to get maybe 4 times 2, you have 8x1 and the rest. It is gradient I'm looking for. They gave me a point, so I'll simply go and substitute this point. I'll say dy dx at the point 3, 1 is equal to minus open bracket 2 times, in place of x, I'm going to put a coordinate which is 3, and then plus, come over here, 4 times, this is y squared and y is 1, you square it, then times this 1 here, alright? Then everything all over, come here, 4 times 2 already will give us what? 8. Then this x has the value of 3. And then this y has the value of what? 1. You can see the coordinates, then plus 5. So do you see that the gradient, which is dy dx at the point 3, 1 is equal to, if you sum out this, 2 times 3 will give us what? 6. And then 4 times 1 square is 1, so 4 times 1 is 4, times this 1 is also 4, this part is 4. 8 times 3 times 1 is 24. Then you know you have 5 here already. Add that of the numerator, 6 plus 4 is 10. They have minus here, so that is minus 10 all over. 24 plus 5 will give us 29. This is the required gradient of this curve at this point. Now let us solve this example number 2. Find the gradient of y squared sine 2x equal to x cos 2x at the point pi over 4, 1. This problem is also an implicit function problem. The reason, because of this square on this y. Is that okay? So we're going to solve implicitly solution. You know what we do already? Or f of x, y. I'm going to move this term to the left hand side. So I'll have y squared sine 2x minus x cos 2x. And then to get my dy dx, solving implicitly is going to be minus, differentiate partially with respect to x. That is the numerator. To do that, what do we do? Let's watch. This is y squared times sine 2x. This is the function of x. The trig function is the function of x. So I'm going to keep y squared constant. Since it's multiplying this function of x, I'll differentiate the sine 2x. Now to differentiate sine 2x, what do you do? Remember our previous videos, you use the concept of what? Minor function and major function. Differentiate a minor, which is 2x, you're going to get what? 2. Then differentiate a major function, which is sine. You get cos. Then cos of the minor function in front, 2x. Okay, now we come over here and differentiate this partially with respect to x. That will be minus. Please, I want you to watch something here. This can be solved using product rule. The reason is because this x is a polynomial function multiplying a trig function cos 2x. There is multiplication between this, you know that. And once you encounter a problem where you have multiplication, you have to differentiate, use product rule. So how do we go about it? I'm going to keep this x constant and then differentiate this trig function of x. To differentiate cos 2x using your major minor function, what will you get? That will be times, differentiate the minor, which is 2x, you're going to get 2 from there. Then times minus, this minus now is the derivative of the major function cos. If you differentiate cos, you get minus sine. So it's going to be minus sine 2x, sine of the minor function in front. Alright, I am done with the first part, keeping x constant and differentiating this. I'll now put plus. This time around, I'm going to keep cos 2x constant and then differentiate this. That is x. If you differentiate x, what will you get? 1. Guess you're done with that part of differentiation with respect to x. You enclose everything in brackets. Divided by, this time around, you go and do del f del y for the denominator. Differentiate with respect to y, you come over here. This is y squared times sine 2x. So you keep this function of x constant. Sine 2x will be kept constant. And then we'll differentiate y squared. If you differentiate y squared, you get 2y. Then come over here and then differentiate this with respect to y. I ask you, is there any y in this term here? Is there any y multiplying it? No. So the partial derivative of x cos 2x with respect to y will give you 0. So we are done with that. Now let us obtain our solution at the given point. But before then, let's see if we can just do a little simplification here, because this is a trig function problem, okay? Y squared times 2 cos 2x will give us 2 y squared cos 2x. Then come over here, this minus times this minus. Or better still, I might still leave that minus outside. Open my bracket. Then we'll have x times 2x times minus sine 2x. Will give us minus 2x sine 2x. And then plus cos 2x times 1 will give us cos 2x. Alright? And then everything will be divided by this times this will give us 2y sine 2x. Now we are going to substitute the point given to us so that the y, the x at the given point pi over 4, 1. Pi over 4, 1 will be equal to, please, I'm going to solve this without showing everything here on the board. I will take you through on how you handle that. Now our x is pi over 4, our y is 1 here, so this will be 2 times minus 2 times 1, I will square it. Then cos, watch something here. If you put pi over 4 for x here, pi over 4, if you substitute it, let's just quickly show it here. You have cos 2, then times pi over 4. These 2 will divide 2 here, divide this 4, you have pi over 4. Once pi appears in front of a trig function, it's having a value of 180 degrees. Is that okay? So this is like 180 degrees divided by 2, which will give you 90. Cos 90 will give you 0. Which means that all this term, if you substitute for x, you're going to get 0. 0 times this 2y squared, in fact, will disappear. So let me say times 0, where this 0 came from, this 2x, cos 2x here. I explained that already. Then minus, come over here, you're going to have open bracket, minus 2 times x, and x is pi over 4, and then sine 2x. Once again, if this is sine 2x, what you're going to have is sine 2 pi over 4. Now, sine 2 pi over 4, in place of this cos, I just explained that here. If it is sine 2 pi over 4, the 2 will cancel the 4, you have pi over 2. Pi is 180 degrees divided by 2 give you 90. So this thing you are seeing here is sine 90. And sine 90 will give us 1. This one already cos 2x is 0. I explained it because it will give you cos 90 at the end, which is 0, so it will go off. Alright, now we are done with that. And close the big bracket. Then divided by, come over here. This is 2 times 1. Then sine 2x. We already obtained the value of sine 2x. If you put pi here over 4, everything is now going to give us sine 90. I explained that already. And sine 90 will give us 1. Once again, pi over 4. These 2 we cancel that over 4 to give you pi over 2. And then pi is 180 divided by 2, you get 90. Sine 90 is 1. So dy dx, which is our gradient at the given point pi over 4, 1, is now equal to, all you need to do is to simplify this term. Remember there is minus outside here. This will give you 0. Everything here will give you 0. Forget about that. Then minus times minus is plus. 2 times this pi, this 2 divided is 4, you have pi over 2 left. So the numerator will give you minus pi over 2 divided by, remember here is 0, this place will give you pi over 2, and then the denominator is 2. All in all, the gradient is minus pi over 4 as our result. Now we are going to look at this example number 5. We are asked to find the equation of the normal line to the curve x squared plus y squared minus 3x plus 4y minus 3 equal to 0 at the point y of 1 equal to 1. What does it mean? It means the value of x is 1 and the value of y is 1. This value is the value of x. This is the value of y. Now if you look at this function, it's an implicit function. So we are going to get our f of x comma y. That is the function of x and y, which of course is what is given to us here. You can see that normally this 0 is meant to cross. But because this is 0, even if it crosses there, it has no effect. So you just neglect it. But if it were to be a number or variable, you have to cross it over. Is that okay? So to meet all the terms here, then you call it a function of x and y. Now previous videos already we had done something like that. So we're going to get our dy dx. Remember you are looking for equation of what the normal line. To get it is very simple. See, the equation of the normal line has the formula y minus y1 equal to n perpendicular x minus x1. That is gradient of the normal line. Is that okay? Now if this is the equation that we need to solve this problem, and then it means we need to get this n perpendicular. This is our problem. We know x1 and y1. Look at the value 1, 1. But how do we get this? We have to get this through the gradient of the tangent line, which already we've treated in our previous videos. How do we obtain the gradient of the tangent line? Proceed to differentiate this function partially with respect to x, and again partially with respect to what? Y. Then dy dx is equal to minus del f over del x all over del f over del y. Once again, in our previous videos, we've done all of these before, so it will serve as a guide. Now, if you go and differentiate this function partially with respect to x, this is what you're going to get. Remember from the formula, you have a negative for the numerator, negative del f over del x. Then all over, go back again and differentiate this function partially with respect to y, and you'll get this. Now, to get the gradient of the tangent line, so that we can be able to get the gradient of the perpendicular line or normal line, what we do from here, dy dx at the given point 1, 1, which represent the gradient of the what? Tangent line, will be equal to, come over here and then you substitute 1 for x and also 1 for y. If you do that, this is what you're going to get. Simplify this and then you get 1 over 6. So we now move on to obtain the gradient of the normal line, which is m perpendicular. And you know the formula is equal to minus 1 over gradient of the what? Tangent line, which if you substitute, it's going to be minus 1 over, our gradient of tangent line is 1 over 6. If you work this out, you get minus 6, because this 6 will go upward mathematically to multiply the one there. Now that we've gotten this, our problem is solved. We can now use this equation and get the result of our problem here. So let's substitute and see. This is the equation of the what? Normal line. So we go y minus, our y1 was given from the problem to be 1. Then m perpendicular, gradient of the normal line is minus 6. Open bracket x minus x1 was also given as 1. So we're going to substitute that. And then our problem is solved is just to simplify, normally in your mathematics. This is going to be y minus 1 equal to, if you open up this bracket, you have minus 6x. Minus 6 times 1 will give us plus 6. And so our result will be y equal to minus 6x. If minus 1 crosses, it will add up to this 6 to give us plus 7. So this could be your result. Or you may choose to move everything to the left-hand side and you'll get something like this, equal to 0. So either of these could be your result. Example number 6 now. This question is a motion problem, and so we need some knowledge of physics. Alright? The question said that the distance traveled by a particle in a straight line in t seconds is given by s equal to 2t plus t squared. Calculate I, its velocity after 3 seconds. I, the acceleration of the particle. Now how do we solve this problem? First of all, we want to look at the function given to us. This is s. which is the distance traveled, is a function of time, t. It means that the distance traveled depends on the time taken. And you know, the concept of differentiation is simple. If I depend on you, you differentiate me with respect to you. Therefore, if s, distance, depends on t, it means we are going to differentiate s with respect to what? T. And so we're going to do, for the first part of the question, remember that velocity is the derivative of position with respect to time, or displacement with respect to time, as the case might be. So for the first part, we say that velocity, which is a function of time, is given as ds over what? dt. We meet this in physics and mechanics when we're talking about motion. And so we are going to proceed to differentiate. Our Vt will be equal to, if you differentiate the position with respect to time, this, what will you get? Come here and differentiate 2t. You are going to get 2 if you differentiate 2t, right? It's just like differentiating 2x. And then plus differentiate t squared, you get 2t. Just like differentiating x squared. And if we substitute the time given to us, it's after 3 seconds. So v after 3 seconds will now be equal to 2 plus 2 times 3. Anywhere you see time, you're going to substitute 3. If you work out this, the velocity after 3 seconds will be equal to 2 times 3 is 6. Add the 6 to 2, you get what? 8 meters per second. Alright? Although we're not told that the distance is in meters, and so I can just write it as 8 units per second. They gave us the unit of time. So whatever the unit of distance is, that's what you put here. Alright, we move on to the second part of the question, II. We are to obtain the acceleration. Remember, acceleration is twice derivative of what? Position. Or first derivative of velocity. So we're going to use acceleration as a function of time to be equal to dv dt, differentiate velocity with respect to time. This is the velocity function we obtained. Is that not so? 2 plus 2t. So we're going to differentiate it to get our acceleration. You come here, if you differentiate 2, you get 0. Differentiate 2t, you're going to get what? 2. So the acceleration is 2 units per square second. And this is the solution to our problem. And now we have example number 7 on the board here. The distance of a moving particle from a certain fixed point P is given by the formula x equal to t cubed minus 12t squared plus 36t plus 2 in the unit meters. Calculate the position of the particle from P when t is equal to 0, velocity at t equal to 0. When is the particle stationary? What is its acceleration after 4 seconds? You see, this question on the board, I am interested in question number 1 and question number 3. Question number 2 and 4, we have already encountered that in our previous videos. It can guide you on that. But question number 1 and 3, very important. Now, what are we to get? In number 1, we are to get the position of the particle from the fixed point when t is equal to 0. What does that mean? Imagine that I'm the particle and this is the fixed point P. At time equal to 0 is the time when possibly I've not started moving. So if I'm just standing here, you know, time is 0, it's because I'm not moving. And so relative to me, I'll take it that time is 0 with respect to my motion because I've not started moving. Now what will be my position from this fixed point? That's the first part of the question. So all we need to do is very simple. Go to the position function and then substitute time equal to 0 in it. You can see the calculation on the board here. The position function is this. So go here, the position when time is equal to 0 will be what? Anywhere you see time, you substitute 0 there. And if you do that, look at, you're going to solve and obtain 2 meters. It means that if this is point P fixed and I am the particle, my position from this point at time 0 will be 2 meters. It simply means that I was not at this point initially. I was at a distance 2 meters away from it before my motion even started. Alright, now I'm going to jump to the third part, but before jumping, let's look at the second part. You have to obtain velocity at time equal to 0. It's simple. Velocity is simply derivative of this x with respect to what? Time. So you differentiate and substitute time equal to 0. You can see the calculation here. Is that okay? Now, let us look at the third part of the question where we are asked, when is the particle stationary? It's very important for you to know the meaning of that. When a particle is stationary, other terms we use for it is the critical point, the turning point. Or maybe with respect to this motion problem, it could be when is the velocity maximum Or when is the velocity minimum? All of them points to this question. They mean the same thing. Now all you need to do is differentiate the position. Alright, that is the distance function. Differentiate with respect to time to get the velocity. Just like question 2. Is that okay? Now when you differentiate the position function with respect to time and get the velocity, all you now need to do is to equate that velocity to 0. The point we're trying to say here is that when the particle is stationary, the derivative of the position, which is its velocity, will be equal to what? 0. You know what that means? If I'm stationary, it means my velocity is 0 because I am not exhibiting any motion. So simply differentiate this with respect to time and then equate towards 0. There is a point there. Remember one application of differentiation, determining the critical point or stationary point or turning point. What it simply means is take first derivative of that function and equate it to 0, solve whatever you have there. So look at it here. Now at stationary point, velocity, which is dx dt, is equal to 0. Already from this second part of the question, we have already obtained dx dt. So all I will do is to equate that dx dt, which is 3t squared minus 24t plus 36. I will equate it to 0. That's the meaning of that stationary point. You can see that this equation you are seeing here, I can still reduce it because 3 is common. So I can divide each term here by 3. If you do that, you get t squared minus 8t plus 12 equal to what? 0. Then factorize this thing. This is a quadratic equation factorized. And how do you factorize? It's very simple. Get 2 factors of this plus 12, which if you add, you get minus 8. The factors are minus 2 and minus 6. Now what do you do to that? You don't need to waste your time that you're really doing full factorization. Those factors, change their signs and divide them by the coefficient of this t, carrying square. So you can play this part again and listen to what I said. Change the sign of the factors and then divide it by coefficient of this t squared. Now we said that the factors are minus 2 and minus what? 6. If you change the signs, you're going to get plus 2 and plus 6. Divide it by the coefficient, which is invisible 1. If you divide 2 and 6 by 1, you still get 2 and 6. So the time during which the particle is stationary occurs at time equal to 2 seconds, the particle will be stationary, it will move. Also at time 6 seconds, it will also be what? Stationary, it will not move. You can walk through the acceleration yourself. It's very simple. That is the derivative of velocity with respect to time, which means you're going to come here, this is the velocity function, differentiate it with respect to time, and then substitute the value of the time 4 seconds given to you. If you solve, you'll get this 0 meters per second. So we have this example number 8 on the board. Obtain the turning point on the curve y equal to x cubed minus 6x squared plus 9x minus 2 and classify them. Alright, we have this question on the board, another application of differentiation. Turning point, I've told you before in previous video, is the same as what? Critical point, stationary point. And how do you obtain it? Simply take the first derivative of that function and equate it to what? 0. Then solve whatever you see there. Now you were asked to classify these turning points. Classifying is to tell us whether the turning points you obtain are maximum or minimum points. So we're going to do that and see what we are going to obtain on the board. First, we proceed with dy dx straight ahead. Differentiate this function with respect to x. You're going to get 3x squared minus 12x plus 9. Alright, so at turning point, at TP, let me abbreviate, okay, turning point, this first derivative will be equal to 0. So we're going to have 3x squared minus 12x plus 9 equal to 0. You can reduce this, you see 3 is common to them, so if you divide 3 by 3, this will give you what? It implies x squared minus 4x plus 3 is equal to 0. So all you need to do is to factorize this expression. If it is factorizable, we are going to look for 2 factors of this constant, which if you add, you get minus 4. Of course, minus 1 and minus 3 we do that, is that it so? In the previous video, I told you how to quickly get the result there. If minus 1 and minus 3 will solve this problem, change the signs of these factors and then do what? Divide each of them by the coefficient of x squared. So we have minus 1. If you change the sign of minus 1, you get what? Plus 1. Divide plus 1 by the invisible coefficient of 1 here, you get your factors that x is equal to 1, or the second factor is minus 3 here, you know, because say it's minus 1 minus 3. If you change the sign of minus 3, you're going to get plus 3. Divide that plus 3 by the coefficient here, alright, which is invisible 1, you are going to get what? Plus 3. take note, suppose this is not 1, let's assume it is 2 now. You know each of these will be divided by 2. So these are the turning points, the critical point, the stationary point. We have obtained it. Very simple. The next thing is to classify them. How do we classify them as to which one is minimum, which one is maximum? All we need to do is to proceed for our second derivative test, which means we are going to differentiate this function now, this one, differentiate it again to get second derivative. That is to say, we are trying to differentiate with respect to x what we already got, dy dx. That's the meaning of that. And this thing is the same as d2y over d squared x. That's the meaning. To get the second derivative of this function, you have to differentiate what you got in the first derivative. And so let's differentiate it and see. This will give us the 2y dx squared to be equal to, I'll differentiate this. It's going to give us 6x minus 12. So we are going to use this second derivative to carry out our test in order to classify these 2 points. Now we want to classify these turning points 1 and 3 to find out which one is minimum and which one is maximum. To carry out that test, we need our second derivative, which we already obtained as 6x minus 12. What business does this second derivative have in the classification? Alright? At minimum point, this second derivative, okay, at minimum, that is a mean point, you expect that d2y dx squared at that critical point, at that turning point, is expected to be greater than 0. And then at maximum point, that is if the critical point is a maximum point, you expect that the second derivative d2y d squared x should be less than 0 at that turning point. So what do we do? Let us now use this to find out. I will go to the second derivative here. There is the 2y dx squared here, the 2y dx squared at x equal to 1. Say I'm substituting this point now. Let's check what we are going to get. To give me 6 bracket 1 minus 12, which of course will give us what? Minus 6. Now I'm going to ask you, this minus 6, is it not less than 0? It's less than 0. Is that okay? And I will say that when second derivative at the critical point or turning point is less than 0, it means that that turning point is what? A maximum point. Therefore, I will say that x equal to 1 is maximum point. Alright. Then we proceed again and then obtain the 2y dx squared at the turning point x equal to 3. We'll come back here and then substitute 3 for x. If you work out this, you have 18 minus 12, which is positive 6. Positive 6 is greater than 0, is that not so? And when the second derivative is greater than 0 at the turning point, we say that that turning point is what? A minimum point. So I will write, therefore, x equal to 3 is a minimum point. You've classified this turning point. You have. And your problem is solved for this. Please, I would like you at the end of this class to go to this function y, substitute this maximum point. Here, anywhere you see x, the answer you are going to get will be the maximum point of this function. Then again, substitute x equal to 3 there for x, then simplify. Any answer you're going to get is going to be the minimum value of this function. Please do that immediately at the end of this class. Let us look at this past question. We are to determine the constants a and b for which this function has stationary point x equal to minus 1 and x equal to 3. You can just play around this problem. It's for you to understand what the question is about. Now, this function has stationary point values at x equal to minus 1 and x equal to what? 3. I know at stationary point, the first derivative of the given function is expected to be 0. So all you need to do to this question is simple. Differentiate this, take the first derivative, then equate to 0 and substitute these points. Now let's do that and see. df of x dx is now equal to, differentiate this, you have 3x squared, plus differentiate this, you have 2ax, plus differentiate this, you have b. At stationary point, you know, this will be equal to 0, so let's just equate to 0 straight. Now at that stationary point, we have that x equal to minus 1. So when x equal to minus 1, substitute here, you're going to get 3 bracket minus 1 squared plus 2a bracket minus 1 plus b equal to 0. If I simplify this will give me 3. Minus 1 squared is 1 times 3 is 3. This will give me minus 2a. Alright, and then this will give me what? B. If I'm to solve that, I'll move this positive 3 that I'm going to get from here to the other side. Of course, we're going to have, if this crosses, I can call this equation 1. If I like, I'll make this positive this first term by multiplying all the terms through by minus 1. If you do that, of course, you get 2a minus b equal to positive 3. Alright, so let this be our equation 1 properly. Then again, at x equal to the second stationary point 3, you would have to substitute here and then equate to 0. You get 3 bracket 3 squared plus 2a bracket 3 plus b equal to 0. If I simplify this will give me 9 times 3, which is 27. This will give me 6a plus b. This 27 will cross to give us minus 27. So you have equation 2. All we need to do is to solve equation 1 and 2 simultaneously and then get your a and b. You can work around that, pretty simple. Now you see that b here and b here have the same value. The difference is the sign. Now you have different signs, you add if you're solving simultaneously to eliminate b. So we're going to add equation 1 and 2. If you add that, 2a plus 6a will give us what? 8a. Then minus b plus b is 0. You have eliminated b. Then 3 plus minus 27 is going to give us minus 24. Then divide through by 8. You get a to the what? Minus 24 divided by 3 by 8 will give us minus 3. So we have gotten a to the 3. We can now get b. To get b, use either equation 2 or equation 1 is a choice. I prefer to use 1. Alright, so if I'm using 1, I will get 2 brackets. In place of a, I'll put minus 3. Then minus b equal to 3. If you solve this, take b to the other side, minus b will become plus b, then this 3 will come here. Of course, 2 times this is minus 6. If b goes here and this 3 come here, you have minus 3, b crossing will give us plus b. So that b is equal to minus what? 9. You see, so a is minus 3 and b is minus 9 for this problem.